Hello everyone, my name is Samyak Kathani and I am a Storage Specialist Solutions Architect at AWS. The topic for our presentation today is Work Smarter, Not Harder, a pragmatic way to meet recovery objectives with Amazon EBS resources. So let's get started. EBS snapshots allow you to take backups of the EBS volumes. Snapshots are incremental backups, which means that only the blocks on the device that have changed after your most recent snapshots are saved. This minimizes the time required to create the snapshot and saves on storage cost by not duplicating data. Each snapshot contains all the information that is needed to restore your data to a new EBS volume. Remember, the first snapshot that you create from a volume is always a full snapshot. It includes all the data blocks written to the volume at the time of creating the snapshot. Subsequent snapshots of the same volume are incremental snapshots. They include only changed and new data blocks returned to the volume since the last snapshot was created. Amazon EBS Snapshots Archive is a new storage tier that you can use for low cost, long-term storage of your rarely accessed snapshots that do not need frequent or fast retrieval. When you archive a snapshot, the incremental snapshot is converted to a full snapshot, and it is moved from the standard tier to the EBS Snapshots Archive tier. Full snapshots include all the blocks that were returned to the volume at the time when the snapshot was created. Amazon EBS Snapshots Archive offers up to 75% lower snapshot storage costs for snapshots that you plan to store for 90 days or longer and that are rarely accessed. Note that it can take up to 72 hours to restore an archive snapshot from the archive tier to the standard tier, depending on the size of the snapshot. Here are some of the differences between standard snapshots and EBS Snapshots Archive. So standard snapshots use incremental point-in-time backups. What this means is when you create a snapshot of an EBS volume, only the first snapshot is a complete backup of the EBS volume. Any other subsequent snapshots of the same EBS volume only store the changed blocks. That is the differential between the previous snapshot and the next snapshot. When a snapshot is archived from the standard tier into the EBS Snapshots Archive tier, the incremental snapshot is converted into a full snapshot. Use cases for standard snapshots include backup and recovery of EBS volumes. It can also include app refreshes across accounts and regions using AMIs. And it is also used for disaster recovery purposes and ransomware protection across accounts and regions. Whereas for Snapshots Archive, the use case include long-term retention for infrequently accessed backups. These include monthly, quarterly, or yearly backups for compliance or even end-of-year projects. Now the pricing for Snapshots Archive is 75% cheaper than that of the standard snapshots. However, keep in mind that there is a minimum retention period of 90 days for Snapshots Archive, whereas for standard snapshot there is no minimum retention. Next, let's talk about how you can automate and orchestrate your EBS snapshots. AWS provides a feature called the Data Lifecycle Manager or DLM that can be used to automate EBS snapshots and Amazon Machine Images or AMIs. How it works is you can specify a tag on the AWS resource. Then you can mention that tag in the Data Lifecycle Manager tool and specify a scheduling policy as well as a retention policy. Whenever the policy is triggered, Data Lifecycle Manager will create an EBS snapshots based on the tag of the resource that you specified in the configuration. The snapshots are triggered within 1 hour of the schedule. These snapshots or AMIs are deleted based on the retention policy that you specified. You can create retention based on count or based on age of the resource. For example, if you specify the count as, let's say, as 7, then when the 8th snapshot will be created, DLM will automatically delete the first snapshot as it will only maintain the 7 latest snapshots for that policy. Similarly, if you specified age as, let's say, 10 days, then on the 11th day, DLM will automatically delete the snapshot that was created before the 10th day. Use of AWS DLM is completely free, However, the associated EBS snapshots are charged at the standard rate. Amazon Data Lifecycle Manager supports the following policies as a lifecycle policy. Number one, snapshot lifecycle policy. This is used to automate the lifecycle of EBS snapshots. These snapshots can target individual EBS volumes or all EBS volumes attached to an instance. Number two, EBS-backed AMI lifecycle policy. This is used to automate the lifecycle of EBS-backed AMIs and their backing snapshots. These policies can target instances only. And number three, cross-account copy event policy. This is used to automate snapshot copies across accounts. Use this policy in conjunction with an EBS snapshot policy that shares snapshot across accounts. For our first demo, we will only focus on creating EBS snapshots for EBS volumes using the EBS DLM policy, specifically EBS snapshot policy. So let's get started with that. Log into the AWS console. From here, go to EC2. If EC2 is not present here, click on search and then type in EC2 and then click on EC2. This will then take you to the EC2 console page as shown here. Next, from the left navigation pane, scroll down to Elastic Block Store and click on the Volumes tab. Here in my account, you will see these 4 test volumes. For the purposes of this demonstration, I will be using the last 2 volumes listed here, that is the GP2 volume and the IO1 volume. I will be tagging these volumes in order to create snapshots using Amazon Data Lifecycle Manager. To tag the volume, click on the volume ID as shown here. Then scroll down to Tags, click on Manage Tags, then click on Add Tag, and here as a demo tag I will add Snap, and in the value field I will add Yes. Do the same for the other volume as well. Note that these are just example tags. You can add the tag value as per your liking and as per your business needs. Now that our volumes are tagged, we can then go ahead and create a lifecycle manager policy. In order to do that, under the EC2 console from the left navigation pane, click on Lifecycle Manager. Here, next click on the policy type drop-down. From here, select EBS Snapshot Policy and click on Next Step. Here, you will see that you can use 2 types of target resources. One is volume as the target resource and the other is instance as the target resource. First, in the demo, we'll demo how you can use volume as the target resource. So here you need to specify the tag of the target resource. If you remember, we specified snap as the key and yes as the value for our EBS volumes. So let's add that over here. Once you add that, click on Add. Add a policy description. So I'll be adding a policy description as example policy for DLM. Next, specify the IAM role. You can either keep the default IAM role or choose another IAM role as per your configuration. Next, under tags, you can add an optional tag. I will be adding a tag here as the key as name and the value as demo_DLM. For the policy status, just click on enabled so that this policy will be enabled when it gets created, and then press next. Next, you will be taken to the schedule page. This is where you can add a schedule and the frequency, retention, and the time when the snapshot should be taken. You can add a schedule name. You can add multiple schedules for a given DLM policy. However, for the sake of simplicity for this demo, let's just stick to one schedule. Here you can specify the frequency from daily, weekly, monthly, yearly, or even a custom cron expression. For this demo, let's select daily. Here you can specify after how many hours a snapshot should be taken. This can range from 1 hour all the way to 24 hours for a daily frequency DLM policy. Next, you can specify the time when the snapshot should be taken at. By default, it selects 9 UTC as the starting point. Note that snapshot is taken within 1 hour of this time. So the snapshot will be initiated anytime between 9 UTC and 10 UTC. Next, you can create a retention. So for this demo, let's keep the retention type as count. And let's say that that the DLM must be able to retain only 5 snapshots in the standard tier. Additionally, you can also add tags to your snapshot created from DLM. So basically any tag that you add here will be also applied to all the snapshot created from this DLM policy. You can also enable snapshots archiving. But remember that snapshot archiving can only be enabled for schedules with monthly or yearly creation frequencies. So if you have had the frequency set as, let's say, monthly, that's when this option gets enabled. You can also enable fast snapshot restores for the snapshot created from this DLM policy. So basically, fast snapshot restores for snapshots enable you to create the EBS volume instantly with all the performance needed. Next, you can also enable cross-region snapshot copies as well as crossed account sharing for snapshots. Once done, click on Review Policy. On this page, review your policy. Make sure that the target resource tag is correct and the policy status is enabled. Also make sure that the schedule that you've created is correct as per your business needs. And then click on Create Policy. Once the policy is created, you will see the policy listed in the Data Lifecycle Manager console page. Here you can see the name of our policy that we created as demo_DLM. To review more details of the policy, click on the policy ID. Once inside the policy ID, you will see all the details of the policy, including the resource type, as well as the status of the policy, and also the target tag that you created. In this case, it is snap-yes. To understand which volumes this policy is targeting, click on this target tag. This should open a new page with the list of volume IDs that this tag is linked to and that the DLM policy will create snapshots for. This concludes our first demonstration of creating EBS snapshots using the EBS Snapshot Policy from the DLM console. Now for a second demonstration, we will focus on creating or automating Amazon machine image creation for EC2 instances using EBS-backed AMI policy from the DLM console. So let's get started. For this demonstration, we will begin from the AWS console and navigate to the EC2 console page. In order to do that, go to EC2 from here or search EC2 and click on EC2. First, we need to make sure that there is an EC2 instance running and it has a tag associated with it, because that is how our DLM policy will recognize which EC2 instances to target while creating an AMI of. So let's go to instances. Here we do see that there is one instance that I have already created for our demonstration. Next, let's make sure that it has a tag associated with it. So select the instance, go to tags. Here we do see that there is a key and a value with key equal to name and value equal to DLM underscore demo. We can use the same tag in order to create the DLM policy, or we can just create new tags. In this case, I will create a new tag. So go to manage tags, click on add new tag, put AMI underscore auto as the key, and for value we will put yes. Note that this is just an example for our demonstration. You can use any combination for the tags and then click on save. So now this EC2 instance has a tag associated with it, which we will use for our DLM demonstration. Next, in order to create an EBS-backed AMI policy, from the left navigation pane, click on Lifecycle Manager. Next, click on Create Lifecycle Policy. Select EBS-backed AMI. Click on Next. Now here, since we will be targeting an EC2 instance, we don't get an option to select volume and instance separately. We just get an option to add a resource tag. So in order to do that, under key, put AMI underscore auto, and in the value put yes, and then click on add. If you remember that this is the tag we had associated with the EC2 instance. For the policy description, we will give an example policy description as example for AMI automation. You can give any policy description of your liking. Next, for the IAM role, you can just keep the default role or create a new or choose another role as per your configuration. For tags, you can add an optional tag. So in this case, let's add a tag with key as name and the value as AMI underscore auto. Next, for policy status, we will make sure that it is set to enabled. And for the instance reboot, we can keep this as no. However, you can also select it as yes. So if you select it as yes, it will restart or reboot the instance when the AMI is taken. And this is done in order to ensure data consistency. However, for our demonstration purposes, we will keep this as no. And then next, click on next. Next, you will be taken to the schedule page. This page is similar to how we created a schedule for EBS snapshots in the EBS Snapshot Policy. It starts off with a schedule name. I will leave this as default as schedule 1. However, you can give any name of your liking. You can also add any additional schedules for AMI creation. For frequency, we want this policy to create AMIs of the EC2 instances daily. However, you also have an option to select weekly, monthly, yearly, or even a cron expression. We want the AMI to be created every 12 hours. So I'll just leave this as 12 hours. However, you have an option to select any of the following. Now I want this AMI to be created at 10 UTC. So I will change this to 10 UTC. We will keep the retention as count. However, you can also select age. And I want only 5 latest AMIs to be retained. So I'll just leave this as 5. When you scroll down under advanced settings, you have an option to create tags for the AMIs created from this policy. Next, you can also enable AMI deprecation. AMI deprecation enables you to automatically deprecate AMIs when you no longer want them to be used. It basically enables you to indicate that they are on the path of deregistration and that a newer version of the AMI should be used instead. Next, you also have an option to do a cross-region copy for the AMI that is linked to this policy and this schedule. Once this is done, click on Review Policy. In the Review Policy, just make sure that the target resource tag is correct. So in our case, it is AMI_auto and yes. Also make sure that the policy status is set to enabled. And then finally, make sure that your schedule is correct. That is, your frequency and your retention is correct as per your configuration. And then click on Create Policy. Your policy here is created. As we can see, AMI_auto is the newest policy that we created. In order to review more information about this policy, click on the policy ID. Here we can see the schedule that we created for the policy. On this page, in order to see which EC2 instances this policy is targeting, you can click this target instances with these tags link. This will open a new page listing all the EC2 instances that this policy is targeting. Now, whenever this policy gets triggered, it will create an AMI of the EC2 instance that we specified as the target tag. And with that concludes our second demonstration for creating EBS-backed AMIs using DLM. And for our final demonstration, we will show how you can create cross-account copy event policies using Data Lifecycle Manager. So let's get started with that. In order to start with that, from the AWS console, again go to the EC2 console page, either by clicking on EC2 or searching for EC2 from here. In the left navigation pane, go to Lifecycle Manager. For this demo, we will just modify the existing policy that we had created for Snapshot Policy, as that is where you need to first trigger the copy of Snapshot to a destination account. So if you remember, this is the policy that we had created. So just click on that. Then go to Modify. Scroll down where you see Schedule 1 configuration and then click on Modify. And scroll down and click on Cross Account Sharing and enable Cross Account Sharing. Now over here, you will have to add an account where you want to copy the snapshot to. So I will just add an account ID and then I will click on Add. Remember that this is the destination account ID where you want to copy the snapshot. Once done, click on Review Policy. Scroll down and under Advanced Settings, make sure that the account ID is correct and then click on Modify Policy. Now this policy is enabled to copy the snapshot created by this DLM policy to copy them to the destination account. Note that these are the steps that we had to take on the source account. However, we will also need to create additional policy in the target account that we have pasted in the snapshot policy just now for a cross account event policy, so that the target account can then start accepting the snapshots that are being shared by the source account. I have logged into the target account ID and we need to go into the EC2 console page from here. So you can either click on EC2 or search EC2. From the left navigation pane under Elastic Block Store, click on Lifecycle Manager. And from the policy type dropdown, click on Cross Account Copy Event Policy and click on Next Step. Here, provide a policy description for this policy. So in this case, I will just add copy underscore event from source account. I'll add an optional tag with key as name and value as copy underscore event. Note that these are just example description and tags. You can add any as per your liking. Under the event settings, I will have to add an account ID. So this will be the account ID of this source account from where the snapshot will be copied and shared. So just click on add account and here paste the account ID. Once pasted, click on add. In the copy snapshots that have this snapshot description field, you will have to add the description of the snapshots that will be shared to this account from the source account ID. So since I had created a description for the snapshot that are being created in the source account, I will just add that over here. Remember that this field is a regular expression. If you add a dot star here, it will basically be enabled or true for any type of description. But for our demo, we'll just be more specific. So I'll just add the description here. And then next under IAM role, I will just leave this as the default role. But again, you can choose any other role as per your liking. Next, under the copy action, now once the snapshot will be shared to the target account, that is this account, the life cycle of the shared snapshot is linked to how long it stays in the source account. So if you want to copy that snapshot in your own account so that it does not depend on the source account lifecycle, you can do so that even if the snapshot in the source account gets deleted, the snapshot in this target account will still remain. So for the copy action, I'll just add a name over here as copied snapshots. This is just an example again. And next I'll add a target region where I want the snapshot to be copied. So I'll add this as EU West 1, for example. And I can also add a retention. So I'll just add a retention of, let's say, 1 week. So that after 1 week, this copied snapshot will be automatically deleted. You can also enable encryption for the snapshots that are copied in your own account. But for the simplicity of this demonstration, I'll just disable this. You can additionally add a new region here. So let's do that actually. Let's add EU West 2 and I'll keep the retention as 2 weeks for this region. Again, I'll disable encryption. For the policy status, make sure that is enabled and then click on create policy. Your copy event policy has been created. Now in order to view more details about this policy, just click on the policy ID. Here, just make sure that the AWS account ID, that is the source AWS account ID, is correct, and the copy actions that you're doing, that is the target regions where you want to copy the snapshots to, are also correct. In my case, it is EU West 1 and EU West 2. Now, whenever the source account's snapshot policy will be triggered, since we have enabled the cross account copy in that account, once it gets triggered, it will automatically be shared with this account and also be copied into the EU West 1 and EU West 2 regions. And with that concludes our demo for Amazon Data Lifecycle Manager. Next, we'll talk about some of the key takeaways from this demonstration. Number one is use Data Lifecycle Manager wherever possible. This is the best way to automate, orchestrate, and manage your snapshots and Amazon Machine Images or AMIs. Number two is optimize your retention periods as per the business needs. It is very important to understand which snapshots that you want to retain for how many days, and this is how you will recognize the most cost savings when it comes to EBS snapshots, as well as it makes it easier to manage your EBS snapshots. Number three is archive long-term EBS snapshots for lower cost. Since the EBS snapshot tier allows you to save 75% cost compared to standard snapshots, it is very important to recognize which EBS snapshots are suitable to be archived so that you can save further cost on that. And lastly, tag everything. Make sure that all of your EBS volumes in your account are tagged. As we learned from this demonstration, that's how Amazon Data Lifecycle Manager recognizes the EBS volumes and creates snapshots, or even EC2 instances tags are used to create AMIs, and the descriptions and the tags are also used for cross-account copy policy events. And with that, I would like to thank everyone for following along with this demonstration. Have a very good rest of your day, everyone. Thank you.